Right now, you feel completely still. You're not. You're spinning with the Earth at hundreds of miles an hour. You're orbiting the Sun at 67,000. Our whole solar system is sweeping around the galaxy faster still. But once you add all of that up, every motion we can explain, there's something left over. An extra pull. Our entire galaxy is being dragged through space towards something, at over 1,000,000 miles an hour, and for 50 years nobody could say what it was. It hides in the one place we struggle to look. Astronomers gave it a fittingly ominous name, the Great Attractor. Today, we finally explain it. This is a 50-year puzzle, and it's a brilliant one. Because the answer kept changing the closer scientists looked. What began as a single mysterious pull turned into something far larger and stranger than anyone first imagined. In the next few minutes, we'll uncover the leftover motion that started it all, the cosmic blind spot that hid the culprit, and the jaw-dropping plot twist that revealed the real force at work. By the end, you'll know exactly what's pulling us, and the surprising truth about where we're all headed. Let's begin with the motion that shouldn't be there. Here's the clue that cracked everything open. Astronomers can account for all our familiar motions, the spin, the orbits, the galaxy's own rotation. But when they measured how our galaxy moves against the backdrop of the entire universe, a stubborn extra velocity remained. Our local patch of the cosmos is racing along at roughly 600 kilometers per second, about 1.3 million miles per hour, in a specific direction, and nothing nearby seemed big enough to cause it. They could even read this motion in the faint afterglow of the Big Bang, which appears very slightly warmer in the direction we're heading and cooler behind us, the unmistakable signature of movement. So the universe was effectively telling us, you are being pulled that way. The only problem? That way pointed somewhere we could barely see. And this is what made the mystery so maddening for so long. When astronomers followed the direction of that pull, it led them straight behind the most crowded, dust-choked part of our own galaxy. We live inside the Milky Way, and its dense band of stars and dust acts like a dirty windscreen, smothering our view of whatever lies beyond. Astronomers call this obscured strip the zone of avoidance, because it blocks out a significant slice of the distant universe. For ordinary telescopes that rely on visible light, it was a wall. So we had a galaxy-sized tug pulling us toward a region we physically could not see through. To unmask the Great Attractor, we'd have to find a way to look through our own galaxy, and eventually we did. The key was to stop relying on visible light. Dust blocks the light our eyes use, but infrared and X-rays slip straight through it. As astronomers aimed these instruments at the zone of avoidance, the curtain finally began to thin, and structures buried behind it came into view. Sitting almost exactly where the pull pointed, around 150 to 250 million light-years away, was a massive, crowded cluster of galaxies, the Norma cluster. It marks the center of the Great Attractor region, and here's the first big correction to the myth. The Great Attractor isn't a single monstrous object lurking in the dark. It's a vast gravitational basin, a kind of valley in space, into which countless galaxies, including ours, are slowly sliding. Mystery solved, surely. Not quite, because when scientists weighed it, the numbers came up short. When astronomers added up all the mass in the Great Attractor region, it simply wasn't heavy enough to fully explain how fast we're moving. The pull was real, but something bigger was hiding behind it. So they looked further out, in the very same direction, and found a giant. Far beyond the Great Attractor lies the Shapley Supercluster, around 650 million light-years away, one of the most colossal concentrations of mass in the entire observable universe, packed with the equivalent of tens of thousands of galaxies like ours. So the truth is layered, like a set of nested pulls. The nearby Great Attractor gives us a genuine tug, but a large share of our motion traces to this far more massive titan lurking behind it. We aren't being drawn by one thing. We're caught in a chain of gravity, each link grander than the last. And when scientists mapped that whole chain, something beautiful emerged. In 2014, astronomers tried a new approach. Instead of just measuring distances, they mapped the motions of thousands of galaxies, the cosmic currents along which everything drifts. Trace those currents, and wherever they all flow toward a single point, you've found one connected structure. Ours turned out to be enormous. They named it Laniakea, Hawaiian for immeasurable heaven. It spans over 500 million light-years and contains something like 100,000 galaxies, with the Milky Way sitting way out near its edge. And the point, all those currents drain toward the very bottom of the valley, is the Great Attractor. In one elegant stroke, the villain of the story was transformed. It isn't a monster pulling us from the dark. It's the gravitational heart of the home supercluster we never knew we belonged to. But the strangest discovery was still to come. Here's the twist almost nobody expects. We're not only being pulled, we're also being pushed. How can empty space push you? Through the strange accounting of gravity. On the far side of the sky from Shapley lies an immense, unusually empty region, a great cosmic void with very little inside it. With massive superclusters tugging from one direction and almost nothing on the other, the overall effect is as though that emptiness is shoving us away from it. Astronomers named it the dipole repeller. So picture our true situation, pulled forward by some of the largest structures in existence and pushed from behind by one of the emptiest. We ride the current between fullness and void, a humbling reminder that even the absence of matter helps steer where entire galaxies go. So if we're falling toward this great basin at over 1,000,000 miles an hour, will we ever arrive? Almost certainly not. And the reason is, one of the biggest forces in the cosmos, dark energy. The universe isn't just expanding. That expansion is accelerating, stretching the distance between far apart structures, faster than gravity can pull them together. On the grandest scales, that push is winning. So while we drift toward the Great Attractor, space itself keeps opening up beneath the journey. It isn't a destination we'll ever reach. It's more like a direction, a current we ride endlessly, never arriving, through a universe that is slowly, gently pulling itself apart. Come back to that bench, and the stillness you started with. You now know it was always an illusion. You're being carried on a current that spans hundreds of millions of light years, steered by structures so vast we can scarcely picture them. And the wonderful part is how we know. We worked all of this out from inside the very dust cloud that hides the view, using invisible light, the faint warmth of the early universe, and the patient mapping of thousands of galaxies. We were never meant to see the Great Attractor with our eyes, so we found another way. That isn't a story about how small we are. It's a story about how far human curiosity can reach. So let's pull it all together. We found a leftover motion that none of our familiar movements could explain, a galaxy-sized pull toward a hidden patch of sky. Behind the dust of our own galaxy, invisible light revealed the Norma cluster at the heart of the Great Attractor. But the real heavyweight turned out to be the Shapley supercluster far beyond it, with a great void pushing from the opposite side. Zoom out, and the whole picture resolves into Laniakea, our colossal home supercluster, with the Great Attractor as its gravitational center. Not a monster in the dark after all, but the address we never knew we had. If this shifted your sense of where you really are in the cosmos, do me a quick favor, hit that like button. It genuinely helps these stories reach more curious minds. Share it with someone who'd love knowing they're moving 1,000,000 miles an hour right now. And if you want to keep exploring the universe's biggest mysteries with us, subscribe and ring the bell so you never miss the next one. The cosmos is stranger and grander than it looks, and there's so much more to uncover. Until next time, keep looking up.